So what I'm going to do now is turn our attention to the final two examples of functional interfaces we're going to be focusing on here in this introductory part. And these are kind of duals of each other. We're going to talk about suppliers and consumers. And as you might glean from the name, suppliers are going to supply something, they're going to generate something or produce something, and the consumers are going to receive that thing. They're going to take it and do something with it. And in fact, these two functional interfaces are actually used together in various interesting ways to make pipelines and other kinds of ways of connecting stuff together in an assembly line-like fashion. As always, we're going to use the Java Collections framework to show how to use this stuff. So the supplier interface is very interesting. Unlike the other ones we've looked at so far, predicate, function, by function, all of which took parameters directly in the parameter list to the function name, this one is going to not take any parameters, but it will return a value. So it returns a value, but takes no explicit parameters. Although we'll see in practice, there's actually ways of passing parameters to suppliers, which seems a little non-intuitive at first, but it'll make more sense once you see how it gets used. So supplier is a generic interface that's parameterized by a reference type, and get is the single abstract method that's passed no parameters and has returned a value of type T. The example we're going to look at here is kind of a fun one, and it's also going to give us a chance to show off some other modern Java features such as optionals. So the example, which you can find in my EX6 folder, is going to essentially map beings like angels and demons and wizards and hobbits or whatever you want to map that's a being to their most designated personality trait. So as we'll see here, a demon is naughty and an angel is nice, and maybe a wizard is wise and a hobbit is resilient or whatever. So we're just having a map that maps string to string. And then down here, from somewhere, from a file name, from a GUI, from something over the network, who knows where, we're going to get the name of a being. So angel, demon, wizard, whatever. And then we're going to go ahead and we're going to look up in this being map, we're going to look up the name that's been given to us. Now, what makes this interesting is if we're given a name that's already in the map, like being or angel, then we're going to get back its disposition. But if we put in something like, I don't know, Kraken, which is a mythical sort of monster from Greek mythology, what do we get back? We don't have anything registered under Kraken. We don't know what its disposition is. So to make this easy to work with and avoid the dreaded null pointer exceptions that you may have run into in some of your programs so far, we're going to use something called an optional. And we'll talk about what an optional is. An optional basically, as we'll see, is an object that is never null, but either has a value present or absent. And so what we're going to do here is we're going to go ahead and say optional.ofNullable, and we're going to give it the results of getting the being in the being map. So if we got back a string, we got back naughty or nice, then the optional's value will be naughty or nice. But if there was no being under that name, we're going to get back null, and optional.ofNullable will simply create us an empty optional. So we end up with an optional string, which may or may not actually contain a value, but which is never null. That's really the key thing to remember here. The value of optional is never null. It always has a value. It just may be the empty value. Now, down here, once we're done with all this stuff, we're going to go ahead and say the disposition of our being, where our being was the string that we got, is going to be disposition.orElseGet. And what that does is if the optional has a value, it'll return the disposition, like nice, naughty, and so on. But if the value's empty, we're going to give it a string that we want to have printed. And that string will be, in this case, the string unknown. So that's the value that'll be returned if the being is not found in the map. And that's done using supplier lambda syntax. So you can read more about the, you could also use or else. So this one uses a supplier lambda where the call is evaluated each time, whereas this one actually gives the string right there. So this is immediate and this is lazy. Best way to look at that. So let's go ahead and take a look at the or else get method, which is defined in the optional class. And you can see that it takes a supplier, and it's called other. So it's going to be the other value you give back if the value of the optional is empty. And so as you can see here, if value is not equal to null, then we give back the value. But if value is equal to null, we say other.get. And in this case, other.get will be what's returned by this lambda supplier, which is the string unknown. So it's bound to a lambda. But notice that that lambda is not evaluated until other.get is called. So again, it's done in a lazy fashion. It's not actually done until it's actually needed. And when you call other.get, if you need to, if the thing turns out to be empty, or if the value internally is null, which is the same thing as being empty, then other.get returns the string unknown. So that's kind of the way to think about supplier. That's one way to look at it. Let's take another look at an example of a supplier. And this is a much more interesting example. So in this case, this is from my EX7 folder, and this is called CR demo. And CR stands for constructor reference. So constructor reference demo. And you can see we have a couple different variants of this. The first one is going to be one that has a so-called zero param constructor ref, where we're going to define ourselves a supplier variable called factory, and it's a supplier of CR demo. So it's a CR demo supplier. And we're going to assign it the syntax for CR demo : new, which in a sense, or in essence, is a constructor reference. And that is a method reference that will create the CR demo object, or create a new CR demo object whenever the get method on the supplier is called. So you can see down here, we can say factory.get, and that goes ahead and we'll call the constructor for CR demo, and we'll get a CR demo object. And then we can go ahead and say, hey, CR demo object, run, do your thing. And because CR demo extends or implements the runnable interface, it has a run hook method. And when the run hook method is called, in this case, we're just going to print out whatever the value of the string is. So that's the first example of this. So that's kind of a simple example. Now let's go ahead and see how we could do something more interesting. We're going to extend CR demo to make a new class called CR demo EX. And this is going to override the run hook method, so it'll uppercase the string. If you take a look at the run method here, you can see it's going to uppercase the string before it prints it out, whereas before it just printed it out as it was. So now we're going to uppercase it. And then we're going to go ahead and define another test method called zero param constructor ref EX. And we're going to use this to demonstrate how suppliers can be used as factories for multiple zero parameter constructor references. So down here, you're going to see we have two variables, CR demo factory and CR demo factory EX, just two variables, both of which are type suppliers. The first supplier is a supplier of CR demos, and the second supplier is a supplier of CR demo EXs. So they just differ by the types. And you can see how we pass in, or we assign to both of those variables, either the CR demo : new constructor reference or the CR demo EX : new constructor reference. And then we can call run demo, passing in either the CR demo factory or the CR demo factory EX. And the same code in run demo will go ahead and take the supplier that's passed to it and say supplier factory.get, which will either get the CR demo or the CR demo EX object, .run. So it'll either print it in a way that prints the string as it was defined, or will print the string uppercased. And the cool part about this is that this code here totally encapsulates the details of the concrete constructor that's used to create this particular object. So you can have the same piece of code and it gets reused, and we just parameterize what gets passed into it by using the magic of suppliers, which keep track of the right kind of objects to create. So that's a pretty powerful example. The third and final example of supplier interfaces is going to take this concept of constructor reference and kind of make it on steroids. It's going to pump it up a bit. And in this particular case, we're actually going to define a new interface called try-factory, and it's actually going to be used to demonstrate how you can use the same constructor reference mechanisms for constructors with a fixed but arbitrary number of parameters. So you can see here, we're going to have an interface called try-factory that takes 3 parameters, A, B, and C, and a return value, R, and it's going to define a method called of. So you can see that of is going to take 3 parameters, A, B, and C, and then return a parameter of type R. And then down here, we're going to define ourselves an instance of the try-factory interface. So you can say we have try-factory string, comma, integer, comma, long, comma, CRDemo. So CRDemo is the object we're making, and string, integer, and long are the types of the parameters we're going to create. And we call this thing factory, and we assign this to CRDemo : new. So if you look down below, you can see that we actually have a 3-parameter constructor called CRDemo that takes string S, integer I, and long L, and then makes a string by concatenating those 3 elements together. And then down here, we're going to use the factory of method, which we define back up here. We define the of method here. And that's going to go ahead and take a string that says the answer is, and then you're going to take 4 and we're going to add it to 2. So we'll end up with printing out the result down below. And this is a good example of the power of Java method references and constructor references and user-defined interfaces to have constructors with arbitrary numbers of parameters, fixed but arbitrary, which is kind of a cool feature. C++ has capabilities much like this too, with variadic templates, which are even more powerful than what you find with Java, but the Java features we're looking at here are pretty neat. So that's the end of our discussion about supplier functional interfaces. We'll see a lot more about suppliers later. We're definitely going to look at suppliers when we talk about the Java Completable Futures framework, where they have some really interesting uses for being able to start computations running asynchronously in the background. So we'll get a chance to talk about that later in the course.